Welcome everyone to this webinar about supply planning and optimization. For today, we'll start off with some brief introductions. Who are these panelists? Which perspective are they representing? Then we will go into the real panel discussion where we talk about the current challenges, some best practices from their experience and some real world approaches that you can learn from. And then we will go into the actual Q&A part. So if you have any questions, you can put those in the Q&A section, and at the end, we will have a look at these, direct them to the different panelists. So first of all, I want to thank and welcome each of the different panelists who all represent a different perspective as well. So first of all, there is Cristina Radu, who is based out of the Netherlands. She will be representing the solutions implementation perspective. She's implemented a lot of different optimization solutions, such as OMP, Arkieva, O9, Anaplan, and she has as a background a PhD in math. So very much welcome, Cristina. Thank you for being here.
Thank you, Ben, for the invitation. Looking forward to the conversations.
Yes, me too. Then second, we have Andreas Feldmann, who will be representing the academia perspective. Andreas is based out of England. He has a background PhD in computer science and has been a researcher and professor on operations research for quite some years, and currently also consulting different companies on the topic of optimization. So welcome, Andreas. Thanks for being here.
My pleasure.
And then the third panelist is Johan Pols, who will be representing the industry perspective. Johan is based out of the Netherlands as well, has a background in industrial engineering, and has been in supply planning and supply chain management roles at different kinds of companies like Eastman Chemical, Unilever, Duc Fine Food, and many others. So thank you for being here, Johan. Looking forward to your perspectives.
Looking forward to the discussion.
Okay, and then very briefly, myself, Ben van Delm, based out of Belgium, background in economics and management information systems, co-founder of Horizon, an advanced planning platform. And my role for today will be to moderate the discussion and to guide the Q&A at the end as well. Now, before we go into the real discussion, just very briefly, some loose definitions up front so that all of the attendees are a bit on the same page about what we mean. With supply planning, we're not talking about the demand planning part, for instance. We're not talking about actual operations. Some people confuse these different things. It's really about translating the demand into specific inventory positions, production quantities, and some define it more broadly, so want to achieve other plans as well. But the optimization perspective is really about a structured approach to make optimal decisions from a mathematical perspectives through heuristics, so specific methods, approaches, or real mathematical solvers, typically with equations where you include specific constraints for a business. Okay, so supply planning, you can create a plan, but it might not be the best plan. Optimization can take care of the best plan, but it's always around a specific objective, about minimizing or maximizing something specifically. Now, very briefly, I want to mention Optimization for All, which is an initiative that was launched a couple of days ago by a group of people, amongst which are Cristina and Andreas. I think it's a great initiative because they want to make the topic of optimization accessible and understandable for people of different disciplines, so business people, researchers, actual planners. So be sure to check that out as well afterwards, I would say. With that introduction, let's start with the actual panel discussion. We will not be using any slides for this. We'll have a real discussion like humans, let's say. And we will start with the situation as is, so with the current challenges. And for that, I want to start with Johan's perspective on how is supply planning and optimization in some companies currently being done, and what are some challenges with that you see?
Yeah, so thanks Ben for that. What we see today in many companies is that most of the planning is still done within Excel, right? So even if you go towards tools like OMP, Arkieva, and the name, you still see that planners tend to revert back to Excel because they need, or they think they need, flexibility because the data is crappy, or the tool is there, but they don't understand what the tool is telling them. So they go back because they need to explain why things are the way that they are. And I think that is what we see a lot today in the as-is situation, where you see tools are being implemented, but it's very difficult to get there. I think that is, and I think another part is what you see is around skill gap. Sorry about that. My cat is
That's
running
fine. And extra panelists in there. I haven't
in front of
announced
me.
the cat, but
Yeah. No, so the skill gap is also something what you see a lot, right? You still see a lot of planners that are being trained at the vocational educational level, but to understand the optimization tools, you need to have a different kind of skill set in your pocket to be able to understand what the tools are doing. And also there you see that people revert back to the known tools like Excel to make their plans instead of using the more elaborate tools.
Yeah, okay, clear. So it's currently mostly done in Excel by a lot of companies, even if they have some tool in place. For some it works well, some do revert back because of flexibility, explainability, and skill gap. Okay, thank you for that. Cristina, from your perspective, when you do these kind of implementations, what are some struggles that you have seen?
One of the things that come to mind, and I think it's the biggest, is there is not a common language. There is a gap between the technical people and the business people. And when the technical people don't understand the business and the business doesn't understand how the technology can support their work, there is a lot of unhappiness, let's say. And why does this happen? So there are two reasons. So on one side you have, many times when you sell the project or you want to implement the software, you talk to seniors from the vendor. So they are seniors, they know the technical, they know the business, you feel like you're speaking the same language. But when the implementation starts, including the design, more junior people come, and they are not as knowledgeable in business, which of course makes sense because they haven't been in the industry. So they are technically good, but they don't understand the business processes, what kind of activities happen, in which order, who does what, and so on. And this is a problem. On the other hand, if you use implementation partners, like a consulting company to help, they come a bit from the other side. They are more business experts, they have been in the industry, but they are not familiar with the tools, but like really familiar, meaning have they ever implemented a tool from scratch to clean up the data, to implement the data, and so on, you know? So they know features, functionality, but they don't know the technical. So there is a gap there, which I notice this is what creates issues.
Okay. So clear gap between technical business people, and then two reasons. Okay, you have senior people initially involved, then juniors don't know about the business, or implementation partners who don't know the deep technical parts either. So it creates some, okay. Clear.
And then the solution to this, like it would be to, and this is what I noticed in the last 2 years, a lot of companies, they start to hire in-house experts, which have a certain experience, and then they choose them and say, well, that person has used at least 2-3 softwares, so they have a bit of variety. They also have been in industry for 10-15 years, so they understand the business processes. And if we hire them as in our projects, they can challenge. They can challenge the technical requirement, the technical functionality, but they can also challenge a bit the business and say, hey, look, maybe here you can do things like that. So such a person could bring a lot of more clarity and I would say more solutions. Like when you think, well, what should I do in this situation? A person coming from outside, which doesn't have any interest for the implementation partner, for the vendor, from so on, then you can get more solutions, more options, and then you choose whatever you think is best.
Yeah, okay, good. So in-house experts as a potential solution immediately. We will come back to this when we talk about more about the best practices and real-world approach. No, it's fine, good. We'll talk about it later as well. But maybe at first, from Andreas' perspective as well, from academia, what have you seen as some difficulties, challenges, perhaps in bringing some tools to the audience, letting them use it, or any other challenges that you've seen really?
Yeah, so I think we've seen a lot of development in the past, well, probably a couple of decades in terms of the research really coming into being implemented into tools. So we have a lot of tools nowadays. And I mean, one thing that's kind of striking, right, is that a lot of people who work in optimization nowadays, they have like a PhD. And well, obviously there's nothing wrong with that, but in the end, it's a bit striking because it's maybe not really so complicated to set these things up. And well, I think this has historical reasons. Like back in the day, it used to be like, okay, you don't only have to model the problem, you also have to actually implement the actual solver for it. And for this, you need some really deep understanding of the mathematics and how it actually works. But nowadays, you know, I mean, there are more and more tools out there, and I think we'll see even more of those being able to solve more and more complex problems. I mean, you mentioned linear programs earlier, but you know, then you can think about quadratic programs. There are tools for that already. Maybe then in future we'll have tools for convex problems and things like that. So more and more complicated things will be solvable. And well, to get there, I think, I mean, on one hand, obviously the tools have to be built, and that's an ongoing thing. And on the other hand, I mean, you need to educate people, right? You need to educate people in particular on the modeling side. And for this, yeah, I think, I mean, from my perspective at universities, I think it's just not taught enough, unfortunately. This topic is kind of still very niche, even in like computer science where I teach. It's just kind of a side. I mean, it depends on the university, right? But I mean, it can sometimes just be something that the students see somewhere, and maybe they've heard of it, but then they forget about it because it's, you know, in a huge pile of all the other stuff that they learn. So it's yeah, definitely a challenge there as well to educate people.
Okay, so you would say more tools are getting available, so more problems can be solved. However, getting them in the hands of the actual users, that's still a difficulty. And it touches also a bit on the initial problem which Johan explained there, which is the explainability, the ability to understand it. So Andreas, to get those tools to the actual user. So if we now talk about, okay, we discussed a bit of the issues from different domains, but if we talk about how can these be overcome? So how can these tools be brought to the users? What are some crucial elements that you see there to make them understand and use it?
Yeah, right. I mean, you mentioned the keyword explainability, right? I mean, this of course is important. I mean, like a planner wants to explain to the management why this particular solution is in place, right? And so the planner also has to understand kind of what the tool is producing. And I think, I mean, when it comes to explainability, I think there are kind of two things we can talk about. I mean, one thing is understanding or explaining, in that case, the actual model, as in what are the constraints and why is the solution based on the rules that we impose on the model.
Yes.
And I mean, there, of course, you know, educating people in modeling definitely helps. And maybe AI can also play a role here, because in the end, an AI can potentially read these rules and also like then explain in written words so that a human being can understand it, what they actually mean, right? So that's definitely one thing. And then on the other hand, you can talk about explaining the computed solution itself, right? So the actual plan that the solver spits out. Maybe that's a little bit more complicated, I would say. But there are approaches to that. I mean, in particular, okay, when it comes to algorithms in general, there is a research area that's called explainable algorithms, and there, you know, people make an effort to compute solutions which come with an explanation of some sort. And you have maybe seen that even in AI when you use an LLM, like ChatGPT or something, you can ask it to explain the solution. So it would be something like that, right? It doesn't just give you the answer, but it also explains how it got there. And I mean, this explanation in LLMs can be correct or not. That's a different topic. But for solvers itself, I think what you can do there is maybe some what if analysis. You can say like, oh, I see the solution, but why my intuition tells me that maybe this, I don't know, this should look a bit different. And what if I just fix this in the solution and compute what the rest would look like, and then compare these solutions to look at why it makes sense somehow.
Okay. Go ahead, Johan.
And yeah, indeed, when talking about explainability, I think what is most important is that in the end, that as a planner, you need to go to your leadership and explain why you are proposing a certain plan. So why are the choices that you are proposing for them to decide, why are those the right choices to make? And I think that is the most, maybe also the most difficult part, but that is also the most important part of any kind of optimizing tool that we are using. Because if a planner is not capable of explaining why we need to do a certain supply plan or do a certain purchase plan, and he can't explain why the system is proposing that, then you see that the management says, okay, go back, do your homework, because they want to understand why they are making a certain decision. 9 out of 10 times, they're not questioning the model itself. They're questioning, why do I need to make this kind of decision? Because there is money at the table. And I think that is why you still see that we still go back to Excel, because that is where the planner has his understanding and he knows what he is doing. And that's what you see a lot, that they either take the results, go back to Excel, make a compute themselves, and then go back to management to explain, this is why I am proposing this solution. And I think that is that's the most important part. And if we can't, as specialists, if we can't teach the planning community how to explain those results, then it will stay a niche product. So I think that there's where, and I do think we can use AI there, because then at least you can make it explainable instead of getting all kinds of mathematical formulas.
So, like Andreas pointed out, there are 3 parts. The actual model, what are the constraints? So what kind of business requirements are taken into consideration? Is the model complete in that sense from a business perspective? Where if that's a document where these are outlined, the rules in text, okay, maybe an LLM could have potential to explain that. Secondly, when we talk about the computed solution itself, the actual equation and details to how it's optimized, that might be more difficult for an LLM. And then there's the what if analysis, where, okay, you try out different things, you see how does it evolve, is it reasonable? The algorithms, the explainable algorithms, is that something, Cristina, that you have seen, or how have you seen this explanation from the actual tools to the users in practice?
So before I answer to that question, I want to say something which maybe most of you know, that optimization is perceived as a black box. And what does it mean? It means that people think that you cannot explain the results. But that's not correct, because mathematics, that's the nature of mathematics, is precise. If you have an equation and an input data, you know what's coming out of it. So this is not the reason that we should not implement optimization tools, because we cannot explain them. We can explain everything. You always trace back to the data or one of your equations if there is something wrong in the model. And about the explainability, but let's say you need an expert who can spend 2 days to find the issue. But I've seen in some softwares which invested time and money to develop a tool. This was even 10 years ago, so without AI, which was pinpointing the issues, because let's say 80% of the time it's always the same issue, the same type of data. Capacity is not correct, or rate is, So they had this kind of decision tree. Did you do this or did you do this? When you did this, did you see this or did you see this? And so on. And in a few minutes, they were able to alone, without an expert, without a consultant, detect the issue and fix it. And 99% of the time is data. So it's something which is in their power to go and check. But this tree algorithm was pinpointing which data, because that's the problem in the solver, that it's a huge amount of data. So if that was possible in some softwares, I think it's possible in all the softwares. It's just up to the vendor to invest, or the people to ask for it. Say, hey, we need this.
Yes, I think that's a good point there, to flag those kinds of data anomalies, perhaps, or it's also something that somebody here in the chat puts to do score analysis, which constraints might be broken, and that could be because it's wrongly defined. So then you figure that out because of it being flagged up, actually. Okay, that's clear. Now, this relates also very much to the explainable part, showing the actual constraints that are used, whether it's the right model, the right data. Then it also relates to the skill gap that we talked about initially, because it will be something else than Excel that a user will work with. So how can that transition take place? Johan, perhaps starting with you from a company perspective, is the matter of, look, here's a tool, this is the optimization, take care of it, or how does that?
From a company perspective, it's of course about educating the people that need to work with the tools, right? So you bring them along. You need to educate them, and what you will see in practice is that some people will be able to get to the next level needed to work with these kind of tools, and there are people that will not make it. And I think that is something that has happened also before AI, right? This is nothing new. This is what you see continuously over time, is that the roles of people will change. And especially if you look at planning, planning 30, 35 years ago was filling out a spreadsheet, plotting what we would make tomorrow. Today we are looking 2 years ahead of time, trying to figure out what are the right choices to make, with more complexity, but also more variability in the plan. So you need a different skill set. And what you see is that although people might understand the supply model or the supply chain model and know how to plan, they might not be able to get towards that next level of understanding how to do the same thing, but now with an optimization tool, instead of putting numbers in place yourself and trying to fix what's going on. And educating them, I think that's the challenge. And what you will see along the line, you will see that people will not be able to make to bridge the gap. And for those, you need to find a different solution, right? It can be inside of the company or even outside of the company. It's but I think that is not only for planning. That is
it's a fair point. Of course,
when roles develop.
Yes, when roles develop, it's indeed it's independent of new methods that is being used. Just techniques change, the business might even change. So resistance to that or openness to learning is always crucial. That education part and getting the users fully involved, Cristina, how do you see that from an implementation perspective?
What I see is that basically, because this is what's let's say, the beauty of supply chain, that all supply chains works the same, right? It's always about the material flow. Basically what I'm trying to say is that you can capture that in equations in Excel. This is what the planners do. They have the equations, the constraints in Excel, and then they just move them to a software. So there is no change in logic, there is no change in constraints, there is no change. So if they understand how planning works and optimization works in Excel, they can understand it in a software. What the software brings more is first the integration, that you can integrate the data, the automatization, the end-to-end visibility in a network, which you cannot do in Excel, to have an Excel for all the regions of the world. And then, of course, you have this element of optimization, which brings you a better plan than what you can do in Excel. But the principles are the same. Nothing changes. And here I also want to say that people think that, if we use our optimization model, this is the solution. No, that is the mathematical solution, but that's different than the business solution. And for the business solution, you need the planner, because he has the business knowledge. So he takes the mathematical solution and enriches it with his industry knowledge. and then you get the business solution. And then how can a planner enrich the mathematical solution if they don't understand it? They are supposed to understand, and they do, because it comes from Excel. And that's what I said at the beginning. There is this perception of black box, we cannot understand it, and that's not correct. Of course, a planner should not know mathematics or how to say, debugging tool, technical, like what Andreas said. They don't need to implement a solver like the technical part, but the optimization reflects the planning process. And if they can do it in Excel, they can do it also in the software. So for me, if is one thing you can remember from me is this, that you can educate everybody. And of course, it's a learning curve, and you need patience. You need a person who doesn't speak technical terms all the time and explain everything in plain English. But I've seen it. I've seen it many times. And in those projects, the planners become the masters of the tool. They become experts, and then they enhance the tool. They find new ways to use it. They become very knowledgeable, very, how to say, creative. They say, oh, what if we do this? What if we do that? They are not intimidated by the tool when they have this transparency. They understand the formulation. They understand it's exactly what they are doing in Excel with some extra benefits.
Yeah. So it's about capturing their current process, making that into clear rules, but they should understand initially their current process and what's happening in the business. And that's just translated into something mathematical. And then you need some technical parts to actually run that. But you say if you take them through that step by step from where they are right now, then they can understand what is considered in the model. And they can even change a parameter if it changes within the business context. So it's important, if I may rephrase you, then to get them involved from A to Z and not just say, look, we implement it, we get the business rules out of your, no, get them from start to finish so that they can then run it afterwards. Yeah. That's okay. So, exactly. And on that skill gap, and also Andreas, you mentioned it initially, these tools, more tools are becoming available, and so you don't necessarily need PhDs to get these implemented in a company. What do you see there in terms of the skill gap of training people? Does that happen within academia? What are some best practices to get people up to speed on those new tools?
Well, I mean, I guess it's up to the universities to make sure that these optimization is in some way or other taught in the curriculum, right? That's, I guess, the easy answer to that. But maybe if I can just make a comment to what was said before, sure, about like tools and optimization. I think it's a very good point that, you know, we should always see these things as tools, and they're not there to like replace anyone. And that can even be said in a more general way about AI, right? Everyone's talking about AI and how this will take everyone's job. And like Johan said, I mean, you know, some people will not be able to adapt, and yeah, that's a pity. But I mean, if you can use this tool, which it is, to your advantage, then you can build much more amazing things, right? And the same is true for optimization. I mean, yeah, it's true that it's somehow seen as this black box, and yeah, if we can educate people on how it works, then it's a massive tool that can be used to produce like very nice solutions, and that's how we should see it, really.
Yeah, if I can add to that, I think that if you look at best practices out there, is what you see that there is a good collaboration between, and we talked about the in-house expert earlier. I think that having a middleman translating business requirements into technical requirements, and whether that's in-house or that you hire somebody with that perspective, I think both are okay, but what you see is in the middleman taking the planners along, understanding the business requirements, translating that into the technical requirements, and work together to install the optimization tool and make sure that it works. Then you indeed see the enthusiasm of the planners arise as soon as they start understanding it, and with that, they start using it. So in that sense, making sure that you have understanding throughout the chain from planner to the technical expert, I think that is important.
Yes. Okay. Very clear. Maybe an important point, and I also see some things here in the chat. I mean, we've already mentioned a couple of companies for which, for instance, Cristina has implemented solutions. But there are many other tools out there as well. I think I see Geoffrey and Meinolf, they're talking about Inside Opt, I know, as well as Timefold. So those are some tools that are used. There are these other providers. There are also, there's OR tools, there are Python-based tools. Maybe, Cristina, can you briefly touch on some of these? Probably some of these are also mentioned in the optimization for all hub. But let's briefly touch on it, because I do see some comments and people wanting to put forward their tools, which I'm fine with. We don't go into full marketing here of different tools, but I do want, it would be nice to get a bit of an overview. What kind of tools are there for people to do it themselves, to do it with a partner? Can you maybe sketch a bit of that?
Okay, so I'm talking about strictly supply chain. So the common practice in supply chain is that, hey, let's implement a planning tool, which the main benefits are this automatization, integration, end-to-end visibility. And then we might get to optimization. So optimization is like a module on the top of a huge planning tool, which takes years to implement. But somehow, sometimes people think that this is the only way to optimization. But you can only install optimization. For example, you can do planning, data, and so on in your ERP system and install an optimization tool. Like, for example, you mentioned OR tool. That's free. It's in Python. Yes. It has open source solvers. So if your company is small, you don't need to install a €2 million planning tool. You can just use even Excel, even the ERP system, and enhance it with all these open source tools that are out there. Of course, in supply chain, when companies are very big, they need a lot of computational power. So it's not about sophistication, but power. And then, yeah, you need to pay for that. But before you do, check if you actually need a planning tool, or just you're happy by planning in Excel and you want to enhance that. You're happy planning, I don't know, in another tool. And then from optimization, you can also attach a reporting tool. So the results of the optimization go to the reporting tool, which this happens already. So this is the only thing I would say, that I have nothing against planning tools. Sometimes you need it, but sometimes the one you have, it's okay, but you just want to make the plan better, and you just attach an optimization tool, and you say, well, but then what's the benefit? Well, the benefit is it's very fast. Because you implement a planning tool, it can take 1 year, 3 years, depending on the size of the company. But an optimization model is very is very fast to implement. You can do it in 2-3 months. So then, and it's also much cheaper. So that's my comment.
Yeah, that's a fair point. I think in the different scales of complexity and ways to implement yourself or with partners, you can start at smaller scales as well. I see some more comments coming up. Okay, maybe Andreas, Johan, or Cristina, before we go to the Q&A section, does any of you still have any points that you do want to get across on any of these topics?
So one point I would like to say is that I also see, let's say, a problem with some tools. They are not very user-friendly. And this is one of the reasons that people go back to the Excel. As Johan said, they offer flexibility. You can do things quickly. But then when you open a planning tool which has 100 buttons and so much functionality, and it takes 40 clicks to see your demand, then that's a problem, you know. So we need to develop tools which are more user-friendly, a clean thing which does 3 things and does them well. So when you choose a software, I encourage you to think about that, because when you have to use that tool every day and you need to do all those clicks which are unnecessary, it becomes frustrating. And you also lose the planners in the implementation phase when they need to test and they need to validate, and they need to do that on the top on their business work, and they need to do all the clicks, and it's a bit frustrating.
Yes, it's true.
So this also contributes to this resistance to change.
Yeah, exactly. And I think it's a fair point there, because especially in supply chain, we're very much, most people are very much numbers driven, focusing on the actual algorithms and everything. But the user friendliness is very important for planners who are in it on a daily basis. So sometimes you might think, oh, who cares that it doesn't look good? Well, if you're in that day to day and you have to indeed go through even many clicks, that is important and does get users to churn. So I think that's a very fair point. Now, okay, I think we've covered a lot of interesting topics and also some best practices or ways to overcome things like explainability, focus on user friendliness, involving the right people in a project that are both technically and business oriented, which might not necessarily be the software provider or the implementation partner, but can be someone independent. Now, let's move on to the Q&A section. I see some questions and some chat popping up. So people, if you have any questions, don't put them in the chat, but put them in the Q&A. I'm fine with you having a discussion on your own in the chat as is going on right now. But maybe also one question that I do have is, not every company has to get a full optimization solution, or as you say, Cristina, start from scratch. What is typically the kind of complexity? Is there any sort of tipping point? Of course, it's not a 1 or 0. It's not that clear cut. But does any of you have any indication of when should you try to implement a structured optimization solution versus just running it in Excel? Is that anything where you have experience? Maybe Johan, we'll start with you from practice from different companies. Do you have any indication of that?
Yeah, I think that it is about complexity of the decisions that you want to make. I have seen situations where we're talking about raw materials and we only had 5 vendors where we could buy one certain type of raw material. But the complexity of buying the raw material over time, with pricing, with quality of the product, etc., made it so complex for a human to compute what is the optimal situation that we have built a linear programming model for that to compute all the possibilities and come up with the right or the best solution for the long term. And we always did that very manual in an Excel environment, which was good, but not good enough when in a later stage they became more scarce. So I think complexity is the driver for having optimization tools in place. And that can be because you have many variables, like although it was only 5 suppliers giving you one feedstock, or where you have many items. I've had a situation where we were running a shop floor controlling with 2,000 orders, 20,000 order lines, and that was only order lines that were actually released onto the shop floor. Yeah, planning that manually is simply impossible because of the sheer numbers. So you need some kind of tooling, in this case a heuristic model, to make sure that you understand your constraints. You build them into your model, and then your tooling does what you as a human cannot do yourself, and where Excel is simply not good enough for anymore.
Yes, it needs to be a certain degree of complexity. Indeed. Cristina, Andreas, anything where you see that tipping point?
I can add to what Johan said by giving an example. So there is, let's say, or whatever, you have all the companies which are global, and say, well, because we have operations, I don't know, everywhere, we need a planning tool to bring the data together, to have this visibility, what I mentioned. But then they install the tool and you realize actually they were doing the planning by region, and the regions, they don't connect. There are no flows between the regions. So actually they didn't need the planning tool to plan globally, when even after they install the tool is still done by, like, one person was doing it in Excel for France, and in the software the same person does it for France, and it doesn't intersect with the other regions. And as it happened, also they had 2 requirements which are the most important, but that tool was not technically capable of doing it. And then they had to buy new products and workarounds and so on, when all they needed was Excel with a little bit of optimization on the side. That's all they needed. But they ended up implementing all over the world this huge tool, which was not doing the 2 requirements they really needed, and was also not a global tool, because everybody was still using it in their country. Nobody was checking what the other region was doing. So you also need to think about that. Do you want to plan in the same optimizer 20 plants? Yes, perfect, go for it. If you have only 1 plant, you can, as I said, do it in Excel. And if it's not good enough, buy an open source or use an open source, or buy a solver which is not that expensive.
Yes.
Yeah.
Okay. So indeed, again, level of complexity depending on the amount of plants, logic that can be put into those different plants. Like Johan said, number of SKUs, raw materials, these are all drivers of whether you should look into it or not. Oh, okay, so another question relates to the use of AI and Gen AI. So the question here is, what can it be used for? We discussed briefly about it. I mentioned also LLMs for that explainability. Andreas, do you see any concrete things for that, for current LLMs, or perhaps other approaches, other research that's going on that can help there? I mean, we in our previous discussion before this webinar, we did speak about, okay, AI, how do you define it? But here, let's start with the LLM part. Very concretely, what do you think it could or could not solve now, and maybe in the future?
That's a good question. In some sense, it goes a little bit back to the question you asked previously, like when should you implement these things? And I think, AI is a huge buzzword. And some people think that, oh, you can, like, AI will solve everything, right? And that's simply not true for some very fundamental reason. Because in the end, I'm talking about LLMs here, right? LLMs are predictive models, right, of what you train them on. And what is that? Well, essentially, let's say the human knowledge, like everything that's out on the internet in some sense, right? So it can produce solutions maybe for things that have already been solved before, but it will have a very hard time to be innovative in any way, right? And this is really where experts come in and will be able to make a change. And I think that's very important to keep in mind, right? That LLMs or AI in general is predictive, while optimization is about planning. And we should kind of keep these things a bit separate. Of course, there will be places where these things will interact. And I can see, again, like if you have a simple thing that you want to solve with optimization, I could see a tool that uses AI in order to produce some sort of simple model and does it, right? But the more complex it becomes, the harder this will be. And in the end, you will need an expert to really check that everything works as it should, right?
Mm-hmm. Yeah. Okay. Clear on the LLMs. On the other research or any other parts where you have seen some improvements, or is that too difficult to see any concrete cases at this moment yet?
Research is of course always like it's basic research, right? So a lot of the things are being researched. Most of that will not see the light of day when it comes to industrial applications. And you cannot predict which parts that are, right? So some parts will, some parts don't. Most will not. But yeah, like I said in the beginning, right? In general, I guess what you can say is that more and more complex types of problems, we will have tools to solve them, right? That's kind of the general thing.
Yes. Yeah. Okay. Thank you. There is another question. It relates. It's an interesting one. It's a bit of a possible guesswork. I have my own opinion about it, but I'm curious to each of yours opinion. The question relates to how much of the scheduling and planning problems in the world, how much of that is currently automated on the one hand, and how much of that is actually optimized through solvers. So the question relates to our solvers mainstream or not within supply chain planning and scheduling. So the question is really about giving a percentage of how much is, let's say fully solved with actual solvers. How much of the planning do you think is the case, each of you?
But my question is, why is this relevant? Because this is a thing we see. Well, let's use the most fancy tool. Do you need it? Sometimes you just need a heuristic. So,
Yes.
so why? And then you implement a solver. They immediately go back to Excel. When with a heuristic, which is also recommended, don't jump from Excel to optimization. Maybe use a heuristic in between. But the heuristic should be custom made to the rules of that company. So then the planners, talking about the learning curve, know the correlation between input and output when they know the rules, because they wrote the rules, right? So then it's not important that all the companies in the world implement mathematical optimization. No,
Yeah.
it's important that each company understands what are the possibilities out there, maybe do a proof of concept, do a heuristic, do an optimization using open source, and then you see what is best for you, because there is no one recipe for success.
Yeah, yeah, that's a fair point. And I agree with that. And I think a lot, if you talk about just all companies in the world, whether it's e-commerce, wholesalers, whether it's manufacturers, many are just smaller companies also, not with such huge complexity. So if you talk about the number of companies, well, not all of them actually need those kinds of solutions. That being said, there are also those anywhere with the complexity that just haven't looked into it. So okay, let's not.
I have maybe
Yes,
an
okay.
answer to that real quick. I mean, I think the answer is very simple. It's essentially almost none. But the reason is that, you know, what does it mean to plan something? I mean, we all plan all the time, right? If I have my dishwasher and I put like my dishes in there, this is you can see it as a scheduling kind of problem. You put, I mean, it's an assignment problem essentially. And I mean, as human beings, we kind of just do it intuitively. We just pack it somehow, like, so that most of it fits in. You know, we use some sort of heuristic on some, you know, very basic level, let's say, right? And I mean, if you go into a company, then I mean, we plan all the time, like, do I go here first or there first? You know, I mean, in which sequence, in which order do I do my tasks? All these things are planning processes, right? And I mean, only the very, very few, like very complex things in the end even deserve an optimizer. I mean, in terms
Yes.
of an algorithm to do it, right? So in that sense, I think, yeah, it's essentially none.
Yes.
But if I can add to it, it's not just like that, because as I said already, sometimes companies in supply chain, they have two constraints, very simple, but they need the power, you know, because if you use an open source solver, it runs for 20 hours. If you use a commercial solver, it runs in half an hour. Even the constraints are very simple. So yeah, that's the problem in supply chain, that you are always fighting with the size, not the complexity. If you go outside supply chain, or let's say a few problems will become non-linear, or there is a little bit of combinatorial optimization, that's a bit different. But yeah, sometimes you cannot avoid the solver if you want to have, like we were talking, scenarios. You cannot wait for 20 hours to run through a scenario, then 20 hours for another one. So having fast, it's very important, and that's where most of the solver companies, I guess they invest both in this performance and then complexity. Because they are in supply chain, they are, the performance is the most important, in my opinion.
Yeah, and I think that if you look at most companies today, even if solvers or optimizers would give them benefit, I think that the complexity for most companies is not worthwhile of going that route. On top of that, you indeed have the skill gap. Many mid-sized, smaller companies, you still need to have your skills in-house to be able to keep running a solver, or you need to hire people externally to run them for you. And I think in many cases, there is not even a benefit, because you also need to understand your model very, very well to build all the constraints in such a way that it indeed gives a feasible solution that is workable.
Yes, it's a fair point. On another question, it again relates to the LLMs, but I do think I just want to come very briefly back on it, because actually it was some time ago that I saw a video of it. I don't recall which tool or who posted it, but the question relates to it. And it is, can you build the model, the equations, gather the constraints, let's say, in a way of just prompting it, getting full text in there from a user, from a planner? That's the one question. Second thing is, maybe anybody of you, have you seen that video or the tool that I speak about? It was like ChatGPT, for instance. You can just prompt it, but it creates equations. It was not ChatGPT. It was something specific for Cristina.
Yeah, I can comment on that. So if you remember, I said the company which built this explainability tree, the same company. Sorry, I lost my thought. What was the question?
Yes, on the prompting. prompting the
yes,
actual
on the prompting, yes. And because of in
constraints.
supply chain, there is a data structure. So like the problem is
right.
kind of the same. All the companies have inventory, demand, the flow, what comes in, what goes out of the node. They were offering the clients an Excel where they were saying the structure. This is what you need to give us: demand, rates, BOM, and so on. And then with the press of the button, the model was generated, all the constraints, and it was 80% of any supply chain solver out there. And then an expert was needed, if still needed, to build on the top of that. So that was already 10 years ago. It was possible without AI. It's just a matter of doing it. And the other thing that you mentioned, yeah, I know the video, but we are not advertising now for companies, which is a bit what Andreas said about the explainability, in the sense that, well, let's say you have a vehicle routing problem, and what if the solver proposes go from Berlin to Hamburg, but a user should write, can we, it's not allowed to go from Berlin to Hamburg, it's only has to go through Paris.
Yep.
And then immediately now, so that the technology we have now, it changes the constraints and it shows the results, but still those constraints were written by a person, but the AI has the power to read in English, because you write in English, send from here to here, there. And then, yeah, it's very easy to see the impact. But again, this works for smaller solvers where you have quick results, because if a solver runs for 1 hour or 2 hours, which is something which happened a lot in supply chain, maybe it's not very useful. So depends.
Yeah. Okay. I will pick you up though on which company that was afterwards. But that's fine. There's here a good question, and it relates again to this about gathering the right requirements, gathering those constraints. And so the question is, what's the best advice that you can give to pose the right questions to the company to gather those requirements and those constraints? There are probably many companies have templates for this. Suppose a company is trying to do this themselves without a partner who has done this for many times, then what are some key areas or any documentation out there that you would recommend that people can freely access? Any of you?
Yes, I have a lot of things to say. I don't know what to start with, because I'm actually prepared. I have a list of questions, right? And then when I go to a client, I have those 20 questions, and then I know what kind of solutions they need. And I also know which software can do those, like, for example, lot size. Just a simple example. If your company is small and you have a lot size and you have it at product level and you also want it at product group level, a software can do it, but another one cannot do it. Or one can do it at product level, but if you want to, for example, group by flavor, right? So it's not by SKU. It's like a group of products, and you want lot size there, which is a fundamental thing of how you plan. Some softwares cannot do that. So you need to ask this, you know? So this kind of like very specific question, because all the users say, we want to have a view to put demand, like very general, very vague. You need to go into this almost shop floor constraints.
Just you were talking about that document that you have, not linking it specifically to software vendors, just getting the right requirements, gathering those from the users, from the people who are involved in the planning. Are there any other resources out there besides your document that you have that you would recommend to people? So that would be something. Or if you want to share that, if that document will be
I know, I will share it. It will go on the website. Yeah, of course. I'm working on it.
Person who asked that question, optimization for all, keep an eye on it. Okay, that's unless Johan, you have any other?
No, what I would like to add to that is one of the things that I've run into in the 30 years that I'm doing this kind of project is that I always I'm mapping out the real supply chain, and it depends, of course, what you try to optimize, but by mapping out the supply chain, by understanding what are your real constraints and what are your imaginary constraints, because some constraints are not constraints. And you need to understand what are the things that are really constraining my plan, and those you need to plan for. By making a good understanding of why you need to plan a certain factory in a certain way, you can understand what your true constraints are. And in many cases, even very complex supply chains where you have a big assembly plans. There was something about metros and buses in the line. You need to, you can chop them up in smaller parts and building with that kind of stuff, but understanding how the physical supply chain really operates, what are the real constraints that you try to plan with, and model those. I think that is it. That's, I think, the key to it. Then you do need to have people that are capable of mapping out that supply chain, making a model out of it, because you need to keep asking the right questions to indeed come up with a model.
Yes, and I can add to that that you should also try to see your how do you say, all the planning levels and the IT landscape, because you have strategic, tactical, operational, and then you want the decisions that are taken in the strategic horizon to travel to the shop floor. But because of the tools you have in between, the decisions are lost, they are not executed very well. So it's very important for us to understand what is your decision model as a company. How, if you take a strategic, it doesn't matter if you do it on Excel or not, how does it translate to the shop floor? And then when you understand that, you can also choose the right tool, because the role of the tool is to support the planning processes, not to fix. Because sometimes companies say, oh, we don't know what we are doing with the planning. We'll do some mathematical optimization and it will tell us what to do. No, the tool is there to support, but you need to have clear who does what and when, and how decision travels through your planning level. So
Yes.
that's the recommendation.
Okay, thank you. So there are still some unanswered questions there. Chat, I see. We can't cover them all, unfortunately. So maybe as a final point from each of you, do you still have any? I'm not going to ask you to do a recap of the key parts, because we have talking about many different things and you don't have to repeat that, but perhaps some final resources that you want to share, because some questions are still related to that. You have like 2 or 3, can be paper, it can be case studies from industry, it can be specific tools, Cristina, that you would recommend people to look at, to learn from. I already mentioned optimization for all, and so let's look at some other ones also. What are some good ones? I will do the same from my end also.
Okay, but I can also start. What it's also included on the website is that I initiated a hands-on supply chain optimization masterclass where I exactly do this, open the black box. And that's not for technical people necessarily, but of course it's very helpful, is to understand how are the equations, how do you think of it, what is the logic in supply chain, and how does it translate into the equation. And the equations are linear, so they're easy to understand for everybody. So if you want to understand a bit this business to technical, you can have a look
at the masterclass. Okay, yes. Good. Thank you. Johan, you have any specific things? Maybe one that you want to close to?
No, to be the one thought that I have is indeed don't try to optimize your complete supply chain in one go. Try to optimize the ones where you can earn the most money.
Yeah.
And what gives you the biggest headache, and start working on that. And and start simple.
Yes. Okay. Very clear. Thank you. Andreas, any final things you want to share?
Yeah, I don't know, in terms of resources, I mean, I'll just say, yeah, optimization for all, just go there. We have a lot of resources there to look at for sure. You know, books, videos, podcasts, a lot of things.
Yes.
Definitely a place to start.
Okay, perfect. Thanks a lot. So with that, thank you to the 3 of you. Thank you, Cristina, Johan, Andreas, for sharing your experience, your insights. Thank you to the audience for the discussion in the chat. It was engaging to follow. Also, thank you for the questions. If you still have any other questions, well, you know where to find these 3 people. You know where to find me. Somewhere in July, I'll also be hosting another webinar that will be with 2 planning people, planning managers. They will share their tools, habits, just to get their work done. So again, something educational from people in the space itself. Don't have a link yet. I see some links being dropped in here from Optimization for All as well. So we'll also share the recording afterwards so that you can look up some of these names. With that, I wish you all still a good day or good evening, depending on where you are. Thank you, everyone. Bye.
Thank you.
Thanks, everyone. Bye-bye.
Bye.